Okay, this question asks us to solve the system of equations x plus 2y equals 7 and 3x plus 4y equals 11. And we're going to do it first with substitution. So let me show you how I do that process. If I'm using substitution, I typically write the two equations in a horizontal fashion, like this. And I determine which of these four variables am I going to solve for, what's the simplest one. And this x is by itself, it has a coefficient of 1, so it'll be the simplest one to solve for. So if I solve for this x, we'll subtract 2y from both sides. And then the 2y's go away, and I get x equals 7 minus 2y. So I've isolated one of the variables. So I'm going to think about it being in parentheses, x is 7 minus 2y, and I'm going to plug it in for x in the other equation up there. So plugging the 7 minus 2y in for x, we get 3, replace x with 7 minus 2y, making that substitution for x again, plus 4y equals 11. Solving here, 3 times 7 is 21, minus 3 times 2y is 6y, plus 4y is 11. Negative 6y plus 4y is negative 2y. 21 minus 2y is 11. Let's subtract 21 from both sides. And we get negative 2y. This subtracts out. Negative 2y is equal to negative 10. Then we're going to divide by negative 2. And we get y is negative divided by a negative is positive 5. And what's nice about setting it up this way is now I can go back to the first equation and plug in 5 for y. So you'll notice I have x equals 7 minus 2y. So we'll say x equals 7 minus 2 times 5. So x equals 7 minus 10. So x equals negative 3. So my solution is a point. The point x is negative 3 and y is 5. You can do a quick check of that. Let me show you how you can check the answer using the graphing calculator. So I will pull that up. So we want x to be negative 3, so I take negative, remember the negative sign is here below the 3. Negative 3, I'm going to store in x, and I'm going to take 5, and I'm going to store that in y. 5 stored in alpha y. And x plus 2y is supposed to equal 7. Let's check it. X plus 2y. What do we get? X plus 2y is 7. That's good. And how about 3x plus 4y? 3x plus 4y is supposed to be 11, and that's good. So we solved it correctly with substitution. And we have a few other methods, but we know our answer is supposed to be negative 3.5 since we've checked it on the calculator. So let's go back and do this question, this time with elimination of variables. So I have x plus 2y is 7 and 3x plus 4y is 11. X plus 2y is 7 and 3x plus 4y is 11. Let's think about eliminating the x's. Well, I have a 1x here and I have a 3 there. Their common multiple of 1 and 3 would be 3. Make them both 3. So multiply this first equation by 3, but make it a negative 3 so it'll cancel. Notice, negative 3 times 1x would give me negative 3x, and that would add to the positive 3x to go away. So that would be negative 3x. Negative 3 times positive 2y is negative 6y. Equals negative 3 times 7. You're multiplying the negative 3 on both sides of the equation. Negative 3 times 7 is positive 21. And the second equation, I just multiply by 1. I don't have to do anything to it, really. Multiplying it by 1, fine. It stays the same. Because you want both of these numbers to be the same, but with opposite signs. So now we have 3x plus 4y is 11. Adding these together, what do we get? Negative 3x and 3x cancels out. Negative 6y and 4y is negative 2y, and it looks like I made an error here. Negative 3 times 7 is negative 21. Negative 21 and 11 is negative 10. Then we divide by negative 2. And we get y is 5. Now you could plug that 5 in to one of your first two equations to solve for x, but I like to eliminate twice. So I'm going to go ahead and solve this problem again with elimination of variables, but this time eliminate the y's. So we have x plus 2y is 7, and 3x plus 4y is 11. 2 and 4, if I make them both 4, they will go away. So let's multiply the first equation by negative 2. That'll make him negative 4y to multiply the positive 4y to disappear. And again, the second equation is just multiplied by 1. No issues there. So as I distribute this, negative 2x minus 4y equals negative 14. Negative 2 times x, negative 2x. Negative 2 times 2y minus 4y. Negative 2 times 7, negative 14. Do not forget to multiply the right side. Second equation is multiplied by 1. Everything stays the same. And let's see what we get. The y's subtract out this time. And we have 3x minus 2x, which is 1x, equals negative 14 plus 11, which is negative 3. So x equals negative 3. So our solution is the point x is negative 3 and y is 5. And we could even put curly braces around that. It's a set of points that includes negative 3 comma 5. So that was elimination. I can also graph these two lines, and I can find the point of intersection using the graphing calculator. So let's take a look at that. So I have x plus 2y equals 7, and I have 3x plus 4y equals 11. This is a little tricky. I want to solve for y. So subtract x on both sides here. And I get 2y is 7 minus x, then divide both sides by 2. And I have y is 7 minus x over 2, which I'm going to put in the calculator as y1 equals parentheses 7 minus x divided by 2. Over on this side, we're going to again solve for y, so we'll subtract 3x from both sides. That goes away. And we get 4y is 11 minus 3x. Then we'll divide both sides by 4. And I get y is 11 minus 3x over 4. And the way I'm going to put that in the graphing calculator is y2 is 11 minus 3x divided by 4. I'm going to graph those two lines and find out where they intersect. Based on my first two strategies, I expect the answer to be negative 3, 5. So let's pull up the graphing calculator. And we can clear all of this. y1, 7 minus x over 2. 7 minus x divided by 2. And then y2 is 11 minus 3x divided by 4. And I usually like to choose a zoom, and I think I will choose zoom standard first. If I can't see the intersection point, I can zoom out. Let's go to zoom standard and see what it says. There is line 1, 7 minus x over 2, which is negative 1/2 x plus 7/2. And there is line 2. So we see the point of intersection here. I'm going to find it using my intersection finder. Calculate. Intersection is 5. First curve is the blue line, fine. Second curve is the red line, fine. Guess, move the man in the spaceship close to where it intersects. And hopefully we will get negative 3, 5. And sure enough, that's my answer. So solving it by graphing the two lines on the graphing calculator, again, we find the intersection point is negative 3, 5. So that's a nice way to check your answer as well as plugging in and seeing where they're going. All right, our next strategy is going to be using elementary row operations. So this is a very nice method, but it can get a little tedious. We have x plus 2y equals 7, and we have 3x plus 4y equals 11. Using elementary row operations, we're going to rewrite this as an augmented matrix. 1, 2 equals 7, 3, 4 equals 11. So what is our goal? Our goal is to solve for x and y. Remember, this first column corresponds to x. The second column corresponds to y. Don't forget that. So this is just another way of writing 1x plus 2y equals 7, 3x plus 4y equals 11. A shortcut way of writing that. So our goal with elementary row operations is to get it in the form 1, 0, 1. Maybe 0 up here, maybe not. At least for this example, I'll go ahead and I'll put a 0 up there too. And those numbers will be the answers. So what am I going to do first? I have the 1. That's always the first thing I need to do. I need a 0 underneath. How do I get rid of the 3? Here's what I'm going to say. I'm going to say row 2 is negative 3 times row 1 plus the old row 2. What's negative 3 times the old row 1? Negative 3 times 1, negative 3. Negative 3 times 2, negative 6. Negative 3 times 7, negative 21. Add that to the old row 2, 3, 4, 11, and you'll see similar numbers that we've seen before. 0, that's what I want. Negative 6 and 4 is negative 2. Negative 21 and 11 is negative 10. This is my new row 2. So my equation is now going to be row 1 stays the same. 1, 2, 7. Row 2 is now 0, negative 2, negative 10. So I turn things into zeros by multiplying and adding. How do I turn this negative 2 into a 1? So that's the next stage of this process. This has got to become a 1 here. It's currently a negative 2. So I'm going to turn this into a 1 by dividing everything by that negative 2. So my new row 2 is the old row 2 divided by negative 2. 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. Negative 10 divided by negative 2 is 5. So my equation has become the following. So we had this in our last version. My new row 2 is now 0, 1, 5. So what do we have? Row 1 is still 1, 2, 7. And row 2 is now 0, 1, 5. Now remember what our goal was. Remember we had that little road map. Our road map was to go 1, 0, 1. This is upper triangular form. This is actually pretty good. But if we want to do it completely, then the last thing we do is we turn that thing into a 0. So I've got to multiply the second row by negative 2 to add it to the first row. So because negative 2 times 1 is negative 2, plus 2 would be 0. So we will say row 2, check that, row 1 is negative 2 times row 2 plus row 1. Negative 2 times row 2, 0. Negative 2, negative 10. Add that to row 1, 1, 2, 7. And what do I get? I get 1, 0, negative 3. That is my new row 1, and now we are finished. We have it in diagonal form. Row 1, 1, 0, negative 3. Row 2, 0, 1, 5. Now let's remember what those columns were. First column was x, second column was y. So this first equation is really telling me 1x plus 0y equals negative 3. Translating this row, into an equation. 1x plus 0y equals negative 3, so that tells me x is negative 3. My second row tells me 0x plus 1y equals 5. So of course, that tells me y equals 5. So again, we have the same answer we got the first 3 times. X is -3 and y is 5, using row operations, sometimes called Gaussian, named after Carl Friedrich Gauss, Gaussian elimination. Sometimes called Gauss-Jordan elimination as well. That's another term that is used for this procedure. Okay, we have Cramers Rule next. So let's talk about how we do Cramers Rule for this problem. We have x plus 2y is 7, 1x plus 2y equals 7, and we have 3x plus 4y equals 11. I've got to remind you how to do a determinant. If I have a matrix like this, like A, B, C, D, the determinant, that's DET, is AD minus BC. So let's just do an example. What if I have the determinant of 3, 2, 1, 5? The determinant is 3 times 5, 15, minus 1 times 2, 2. The determinant of that matrix is 13. So you start upper left times lower right, minus lower left times upper right. So here's how this process works. I am going to put the coefficient matrix on the bottom. Cramers Rule says 1, 3, 2, 4 are the columns. 1, 3, 2, 4 here. So we're going to take the determinant of that matrix on the bottom of that one. Same thing on this one. The second one is also 1, 3, 2, 4. Upstairs, again, we're going to do matrices, but how is it going to change? We have this column of 7, 11. Okay, that's the answer column. It goes in the first column on X. It goes in the second column on Y. And then we move this up. 2, 4 moves up. We move 1, 3 up. 1, 3 moves up. And then we do our determinants. So the first one is X. The second one is Y. So what do we have? 7 times 4 is 28. Minus 11 times 2 is 22. That's on top. What's on the bottom? 4. 1 times 4 is 4. Minus 3 times 2 is 6. 4 minus 6. Here we have 1 times 11 is 11. Minus 3 times 7 is 21. Over 4 minus 6. What does that give us? 28 minus 22 is 6. 4 minus 6 is -2. 11 minus 21 is -10. Over -2, remember this is x comma y. What is that the same as? 6 divided by -2 is -3. -10 divided by -2 is 5. So that's Cramers Rule, again, built out of determinants. Let me remind you of the process one more time of how Cramers Rule works. Coefficients, 1, 3, 2, 4. It's got to be in this order, something x plus something y equals something, something x plus something y equals something. Coefficient matrix, 1, 3, 2, 4, 1, 3, 2, 4, 1, 3, 2, 4 goes on the bottom. 7, 11, the answer, first column here, 7, 11, answer, second column there. And then those match. Notice 2, 4 on the bottom, 2, 4 on the top, 1, 3 on the bottom, 1, 3 on the top, and that gives us an answer of -3, 5. And our last approach here is to do this finding matrix inverses. So let me show you how that works. We have 1x plus 2y equals 7. And 3x plus 4y equals 11. Well, we're going to rewrite this as a matrix equation. It's going to look like this. 1, 3, 2, 4, xy equals 7, 11. So if I think of this as the equation AX equals B, if I multiply on the left by A inverse AX equals A inverse B. A inverse A is the identity matrix, which behaves kind of like a 1. So the identity matrix times X, that's capital X now, is A inverse B. So my answer, which will be capital X is going to simply equal A inverse B. So let's just go ahead and do this on the calculator so you can see how it goes. Again, matrix A, coefficient matrix 1, 3, 2, 4. Matrix B, answer, column 7, 11. My answer will be A inverse B. Let's do this on the graphing calculator. Coming here, the matrix button is what I want to find. Second here, you'll notice second here is the matrix button. And I'm going to edit, I'm going to put a new matrix in there, call it A. That's what I'm using here. Matrix A is 1, 2, 3, 4. It looks like the way I've written this. So that matrix is 2 rows by 2 columns. Okay, and it's 1, 2, 3, 4, first row 1. Then it was 3 down here. I guess that's how it likes me to enter it. Enter. Then it was 4 down here. Enter. And then it's a 2. I guess I didn't go over there. And then there's a 2 here. So I have inputted matrix A. You see that? 1, 2, 3, 4. Matrix B was 7, 11, but that's 2 rows, 1 column. Second, quit. Matrix B is what I'm looking for. We're going to edit that or put that in the computer. So clear that for now. Second matrix edit, matrix B, which is 2 rows by 1 column, and it's 7, 11. And remember what we said we had to do here. Our answer is going to be A inverse times B. So the matrix X, what we have here is this is matrix A, this is matrix X, this is matrix B. So matrix X is X comma Y. That's going to equal A inverse B. So let's do that on the graphing calculator. Matrix, second, matrix, A entered, inverse, the inverse button is right here, X to the negative 1 power, times, if you'd like, matrix, second matrix, B is here, hit enter, and what do we get? Negative 3, 5. That should sound familiar. So we've also done that with matrix inverses. So what I have is I have X is negative 3, I have Y is 5. So my solution is the point, negative 3, comma 5.